Hello and welcome to our part 1, where we will be describing common network application attacks. The first style of common network application attack that we review here is going to be password attacks. And my goodness, folks, I have to say password attacks have been around forever, as long as I can remember, maybe even one of the very first style of attacks. Whether it's going to be something as simple as just guessing the password by nature of knowing the person or knowing the application, brute force attacks over a period of time, maybe even creating a dictionary system of well-known passwords, or more of a social engineering approach by way of phishing attacks. And there are many applications that are available for you, many frameworks, everything from Cain-enabled, Jack the Ripper, all the way to Loftcrack. And I remember using each of these while doing posture assessment of various networks over the years. And keep in mind that these attacks can take place both online and offline, with some people feeling that the offline style of attacks are going to be some of the worst attacks. Two things really do amaze me when we start talking about DNS-based attacks. And this comes from a report that was made many years ago. And that is the first one, how over 91% of malware out there will use DNS as the infrastructure to launch their attacks. And conversely, how 68% of organizations don't even bother monitoring their DNS infrastructure or their DNS systems. Being that so many organizations do not bother to monitor their DNS infrastructure, that makes common sense that DNS servers are so very susceptible to attacks, whether it be from vulnerabilities or even malicious activities. Common ways that malware can use a DNS infrastructure would be through command and control access, exfiltrating data out of an organization, and even redirecting a client of victim's traffic to a malicious destination. Common unfortunate setup that enables this to be an even bigger violation is what is referred to as a DNS Open Resolver, where the DNS server is not even authenticating or restricting non-authorized clients from using the services provided by that DNS server. And as we're going to talk about coming up in just a moment, many techniques that will take advantage of a susceptible DNS infrastructure would be fast flux, double IP flux, and even DGA or domain generation algorithms, with our focus being on the word algorithms coming up in just a moment. Now, of course, we don't want to just leave you afraid of what options are available for attack when we would like to also leave you with what resources are available for securing your network. And that is where Cisco's umbrella cloud-based DNS security services is available for you as part of the Cisco security portfolio of offerings. Continuing our conversation with various types of DNS style attacks, we have fast flux, double IP flux, and DGA. Keep in mind as we're reviewing this, the word flux is meant to indicate fluctuation or changes. So for example, fast flux would be a compromised network of many name servers that will be switched from one name server to another name server to another name server very quickly for the resolution between host name and DNS name. Double IP flux, once again, flux being changing, the double is referring to changing not only the host name to IP relationship, but also the authoritative name server. And then DGA being a change in designated authority, changing in an algorithmic manner, again, the A standing for algorithm, changing whether it be in a random value or random amount of time from one name server to another name server. Continuing our evolution of DNS-based attacks, it is important for us to talk about DNS tunneling, because DNS tunneling can be used by many different techniques to either hide the data that is being pulled out of an organization, exfiltrated out of an organization, or to hide the redirected client, the impacted client's communication to the command and control network. And even more so, the activity being hidden, but also the data that's being exfiltrated, copied out of the organization using different data encoding mechanisms to hide what is actually being copied out. And we're going to show you a couple of examples of each of these three as we continue over the next couple of seconds. So once again, keep in mind an ideal approach to protecting this would be to not only monitor DNS logs, filter the traffic on the edge points within your organization, but also using a service such as the Cisco's Umbrella. So as we mentioned a moment ago, three options that we're just going to very high level review, whether it be the one across the top, exfiltrating, stealing data from an organization, maybe again, patient record information, employee investment information, or across the bottom, communicating with a command and control system. So once again, an impacted client communicating with command and control station. All the way to our third example here of exfiltrating, getting out a user's credit card number by simply tunneling that inside of DNS queries and changing the data format. So again, they're showing you a hexadecimal representation of when you simply change the data format, what would be in ASCII someone's very critical credit card number.